Okay, so this is Chapter 5, the first part of Chapter 5. I'm going to go all the way up through incomplete dominance. These are the weird cases that don't apply to what Mendel has found, and it's incomplete and codominance, and I've been talking about it for a while, so I'm going to start going through it. Before, when we've talked about it, you were either one or the other. So if you look at the pictures of the dogs, the black dog and the white dog, one is dominant, one is recessive. Typically the black is dominant and the white is recessive, so if you were to mix them and you get the black trait, you're going to be a black dog. In the cases that I'm going to teach you about now, however, you can have two different options. So if you look, the gray dog right here is actually what happens when two of the traits, neither are really strong enough, so you get a mixture in the middle. And in the case of codominance, the traits are both so strong that you see them both simultaneously. So I always try to pair incomplete and codominance with words. So incomplete dominance is like a blending. So if you mix black and white, you get gray. Whereas codominance is where you're seeing two things at the same time. So like multicolored or co-op are words that you can use to associate codominance with, as opposed to incomplete dominance is more of the mixing. So that's that. And I'm just going to page through and show you how to actually calculate it. So one of the examples that can throw off Mendel's ratios is called a lethal allele. So anything that essentially kills you is called a lethal allele. A genotype that will kill you is considered lethal. And there's a weird case in humans and in dogs where you get a lethal allele. So in humans, the trait for achondroplasia dwarfism specifically is dominant. So I'm going to use this as my dwarf, and this is my normal heighted person. So if I mix two parents that are dwarfs, in this case, normally you would say that 75% of the offspring would be dwarf, except in this case right here, it's called a lethal allele combination, so this will die as an embryo. So you can only ever exist as heterozygous. And then this one right here will be normal height. So you'll have two dwarfs and one normal height. In every person's body, you only ever have two alleles. But in a population, you have a lot of alleles. You have many alleles in a population because it can mutate. So for example, cystic fibrosis, there's over 1,000 different alleles in the population, but still in our own body we have two. If you think about hair color, we only have two that make our hair color. However, in the population you could have brown hair, you can have black hair, you can have blonde hair, you can have red hair, you can have different shades of each of those in between. And, alright, so incomplete dominance. Let's get into the incomplete dominance. So normally for complete, you see one allele and the other one hides, right? So in the case of hair color with myself and my daughter, I'm big B, little b, right? You see the big B because I have brown hair, and what you don't see is the little b until I've given it to my daughter. But for incomplete dominance, sometimes you need enough of one pigment in order to be able to do it. Actually, that's on this slide right here. So sometimes you do need, this is part of your notes, you need enough of a certain amount of an enzyme. So when you don't have enough, you don't produce enough, and then you wind up with this in-between color. Unlike with hair color, that doesn't happen. Alright, incomplete dominance. In genetics, I'm going to show you how to write it. You're going to erase slide 4 and you're going to put this with slide 5, which is your new slide. So in genetics, when you're writing incomplete dominance, because it's not normal, typically I would be writing big B and little b, right? We've done that before. And then my big B is my brown allele and my little b is my blonde allele. Well, I still have to have two alleles. So I'm going to look at my red flower first. I wanted to point out a key for my, here we go, give me a second. I wanted to point out a key for my alleles. In genetics, you always use a letter with a superscript. So I'm going to use C for color, and then I'm going to put an R, so it's the color red, and this is going to be my red allele. And then I also have a white allele, so I'm going to do C with a W, which means the color is white. The reason why you do the different keys, so here's my one allele, here's my other allele, you do the different keys because it's a different way to calculate it. So if I go back here, and I say, alright, so then what are my alleles? What produces these color flowers? I have a red flower, I have a white flower, and I have a pink flower. That pink flower is that mixture of red and white. So what winds up happening is you write white as here's my first allele, there's my second allele. Both alleles have to be white in order to produce white. For my red, both are red because you have enough in order to make the red pigment. In the middle, though, the heterozygote in the middle is one red and one white, because white and red make pink. I want to show you how to calculate it. So this right here is what you need to copy in your notes. This is your new slide. You erased the original slide 4, and this is your new one. So that's what you need to copy right now. But I'm going to show you how to actually calculate. And it looks like this. So I tell you to cross a pink and a red flower. So my red flower, like I showed you, is red, red. My pink flower is one red, one white. It's not P for pink because you only have red and white. Just like you have a homozygous dominant, a homozygous recessive, and a heterozygous, this guy is a heterozygote. So this flower will be red, that flower will be red, this flower will be pink, and that flower will be pink. So these will be pink because it has one red and white, and these will be red. What I'd like you to do right now is try this one for yourself. So go ahead and pause it and try red with white. And then I'm going to show you what you should get. So you're going to do red with white, red with white, and tell me what you wind up getting. So pause it and do it, and then I'll show you the answer. If you look, here's my red, right? Both have to be red. Here's my white, so both are white. If you look, you should have gotten all of them are pink because they have one red and one white, so it should be 100% pink. I'll do the next part for codominance afterwards, so you can go ahead and stop your notes.